Hello everyone, now we are going to discuss what is balancing and types of the balancing. So we have completed the flywheel chapters. Now we will discuss the balancing chapters. In the balancing, basically balancing we need to require just because of the vibrations. Because in any mechanical system there will be a vibration, so that's why there will be unbalanced force. So we need to balance those forces. Okay. So this is just because of the vibrations. So here I'm just going to write the just because of vibrations. So this is vibration causing. Okay. So just because of vibrations there will be an unbalanced force, and just because of unbalanced force there will be a reciprocating masses and the rotating masses. Two types of masses will be there. In any mechanical systems, two types of masses will be there. The first is reciprocating and the second is the rotating mass. Okay, just because of the reciprocating mass there will be a reciprocating unbalance, and just because of rotating mass there will be a rotating unbalance. So vibration causing, and there will be a reciprocating mass by reciprocating mass, and second is also by rotating mass, and just because of reciprocating mass there will be a reciprocating unbalance. There will be a reciprocating unbalance. Okay, there will be a reciprocating unbalance, and just because of the rotating mass there will be a rotating unbalance. We will see these two unbalancing in detail. Okay, rotating unbalance. Okay, what is the nature of the rotating unbalance? See, rotating mass will be there. Okay, which is going to be rotated about a certain point and having the radius of rotations. It is always constant in magnitude. We know that. Always constant in magnitude, but is changing direction continuously. So the note you can write here, always constant in magnitude. This will be always constant in magnitude, but continuously change in direction, but it is continuously changing direction. So you can see here, when there is a rotating mass which is always is constant in magnitude but continuously change in direction. Okay, so we have seen that the balancing is just unbalancing is just because of the vibration, and just because of vibration causes by the two types of masses. The first is reciprocating masses. If there will be a reciprocating masses in the system, there will be a vibration also. That means I want to say that the contributions in the vibrations just because of reciprocating mass as well as rotating mass. Okay, these two masses contributions causes the vibration, and just because of vibrations we need to balance the system. Just because there will be a vibration is generally there will be a mechanical system, always there is a vibration. So just because of reciprocating mass there will be a reciprocating unbalance, just because of rotating mass there will be a rotating unbalance. What is the nature of the rotating unbalance? Always constant in magnitude but continuously change in direction. Okay, this was basically the reciprocating as well as the rotating unbalance. So the high speed engines, if I'm talking about the high speed engines and the other machines which are going to be used nowadays, very essential that all the rotating and the reciprocating parts should be completely balanced as far as possible. I'm not saying that it should completely balance 100%, but we want that these rotating as well as the reciprocating parts should be completely balanced as far as possible. Okay, so if these parts are not properly balanced, if these parts, that means the reciprocating or the rotating mass, are not balanced, there will be a dynamic forces will be there. Okay, dynamic forces are set up. So these forces not only increase the loads on the bearing but also stresses in the various members. Are you getting my point? If these are dynamic forces which is going to be generated just because of the imbalance in the reciprocating and the rotating mass, there will be dynamic forces, and just because of dynamic forces there will be an increase in load on the engine as well as stress will be developed in the system. Okay. So in this chapter we will discuss the balancing of unbalanced force caused by the rotating mass in order to minimize the pressure on the main bearing when engine is running. Okay, we will discuss about the reciprocating as well as the rotating mass also. Okay, in order to minimize the pressures. Okay, because there will be unbalanced forces in the mechanical system, so we need to balance them. How we balance them? Okay, what is the procedure should follow for balancing them? We will discuss in this chapter. So basically this was the introductions of the balancing, and if I let you know what types of balancing? Types of balancing, basically there will be a two types of balancing. The first is static balancing and the second is dynamic balancing. I'm talking about the unbalanced forces respectively as well as the momentum. Okay, so basically balance having two equations. Balancing having two equations. The first is summation of F is equal to 0 and the summation of M is equal to 0. That is vector quantity. Okay, we need to consider with sign. If I consider a disk, for example, there is a disk which is going to be rotated about an axis. So this is the axis passing through the disk and this is the center of the disk. But you know, there is a when we design the material, when we design any mechanical system, any part of the mechanical system, we cannot design it perfectly. So that's why there will be a center of mass which is not at the center of rotation of the disk. The center of mass, however, the disk is going to be rotated about that center O. Okay, but if I'm talking about the center of mass of the rotor, see this is a rotor. So center of mass will be having offset. Okay, like that. This is an offset, and suppose this distance is basically E. If I consider this distance is E, and this is m r omega square, m r omega square, where is the r is the radius of rotation of the disk of the rotor. Here we have drawn the center of mass which is having an offset from the center of rotations, just because we know that the mechanical system and any part of the mechanical system we cannot design perfectly. Okay, so that's why there will be an error. So that's why center of mass will be an offset from the center of rotation. However, we consider the centripetal force mr omega square. Okay, mr omega square. So we can say this is a force, rotating force working on the rotor, m r omega square, where r is the radius of the rotation. Okay, so there is a two equations. The first is summation of F is equal to 0 and the second equation is summation of M is equal to 0, where M is moment, where F is force. Okay, so from here we can get the two types of balancing. The first is static balancing and the second is dynamic balancing. So if I talk about the static balancing, if I talk about the static balancing, you all understand that I am talking about the summation of F is equal to 0, and we know that F is equal to, so I can write here F is equal to mr omega square. You can see in the equations mr omega square, omega will be constant because the rotor is having a constant angular velocity omega. Okay, so this cannot be constant, so this will be constant, this cannot be vary. If there is a number of parts, if there is a number of rotating parts will be there, so the omega will be same. So here I can write that summation of F is equal to 0 means summation of mr is equal to 0. You can understand this. Summation of mr is equal to 0. This is the static balancing. You must remember this. This is static balancing. Okay. So here we balance only force. Moment will balance automatically. You need to understand the definitions. Sometimes they will ask you the definitions in the examinations. So here I am just writing that Here we balance force only. Here we balance. Here we balance only force. Here we balance only force. And what about moment? Moment will balance automatically. This is the definitions. This is the criteria for the static balancing, that moment will balance automatically. You need not to balance moment. Okay. So moment will balance. Moment will balance automatically. Moment will balance automatically. So this is basically the static balancing. In the static balancing, we only balance the forces only. Moment will balance automatically. So what is the condition for the static balancing? When all the masses are rotating in the same plane. So I am just writing here the condition. The condition for static balancing. All the masses are rotating. All the masses are rotating in same plane. Are rotating in same plane. Are rotating in same plane. Okay, this is the condition for the static balancing. And in the mathematical form, I have written that summation of m r is equal to 0, where m is the mass and the r is the radius. So again, I am explaining that for the balancing we need two equations. The first is summation of force is equal to 0, and the second is summation of moment is equal to 0. When we talk about the static balancing, we need to balance only forces. Moment will balance automatically. You need not to write down the momentum equations, that is summation of m is equal to 0. You need not to write these equations in static balancing. In static balancing, we only balance forces. Moment will balance automatically. So you need to learn this statement also, because if there is a theoretical questions, they may ask you to the multiple choice questions on the basis of theoretical. Okay. So what is the condition for the static balancing? All the masses are rotating in the same place. We will see that the rotating masses will be in a different plane also. But here, when we talk about the static balancing, all the masses are rotating in the same plane. And we have seen in the mathematical forms, we know that the force is equal to mr omega square when there is a body which is going to be rotated with an angular velocity omega. So if omega is constant, we can consider mr, summation of mr is equal to 0. Okay. So this is the basically static balancing equations in a mathematical forms. You just have to know it. Now the second type of balancing I will discuss, that is dynamic balancing. Dynamic balancing. What is the difference between the static balancing and the dynamic balancing? You all understand that static balancing, that means we only balance force, but in dynamic balancing we balance force as well as moments. So here I can write that we balance force as well as moments. That is the difference between the static and the dynamic balancing, as well as moments. Okay, we balance force as well as moments in case of dynamic balancing. What is the condition? When all the masses are rotating in the different plane. Okay, so condition, you must remember that condition is that all the masses are rotating in different plane. Okay, different plane. So that is what the dynamic balancing. In the dynamic balancing, we only balance force as well as moments, and all the masses are rotating in different plane. But in case of static balancing, all the masses are rotating in same plane, and in static balancing we only balance force. So what is the mathematical formula, mathematical conditions? So that would be summation of m r l is equal to 0. This is very important relation. You must remember this. If you, let me write clearly here. summation of m r l is equal to 0. Okay, so this is the equations for the dynamic balancing mathematically. I hope you will understand the types of balancing as well as the introductions of the balancing. Again, I'm explaining that there is a vibration in any mechanical system, and just because of the vibration, there will be an unbalanced force. So we just need to balance those forces, because force not only increase the load on the system, but also it increases stresses on the bearing. Okay, so that's why we need to balance. Okay, however, the unbalancing is just because of the reciprocating mass as well as the rotating mass. In the mechanical system, there will be reciprocating mass as well as rotating mass. So that's why there will be an unbalanced force, and just because of unbalanced force, there will be a vibration. So we need to balance reciprocating mass as well as the rotating mass. If we cannot balance completely, we should balance them as far as possible. Okay, so that is the criteria. So we have studied the balancing having two types, that is first is static balancing and the second is dynamic balancing. In case of static balancing, we only balance force and we a moment will balance automatically. You learn this statement as it is. Okay, in case of static balancing, the mathematical equation is that summation of mr is equal to 0. Okay, and the condition for the static balancing is all the masses are rotating in the same plane. But in case of dynamic balancing, force as well as moments, we balance both of them. Okay, and what is the condition for dynamic balancing? All the masses are rotating in the different plane, and the mathematical expressions, that is summation of mrl is equal to 0. So that is the introduction as well as the types of balancing. I hope you will understand this concept. So